I'm Savannah Buckner.
Hello, I'm Katie Homer.
We're the Secret Society.
And we can hide images as well as we can hide ourselves.
This is the code for our GUI, and we're going to run it now. This is what our GUI looks like. Here's a button for instructions, so you can read the instructions and know how to use it, but we're just going to explain how to use the GUI in this video. The first button is to load the normal image. We'll choose this one and open it. And now we can load a secret image. And then here are the various embedding techniques that we can use. We'll just choose one. And now this secret image is embedded in the normal image. And now if we want to embed another secret image, we can click this button, Use as New Normal Image. And now the embedded image is here as the normal image, and we're able to choose another secret image and choose another embedding method. And now have an image with two different secret images embedded inside of it. Now we can save that one. We'll save it here. And now if we want to recover the secret images embedded in our normal image, we'll load the normal image that we just created. And we'll select the same recovery methods that we used to embed. And we can see this was the first secret image. And this was the second embedding method we used. And there's the second secret image. If we try to use a recovery method that's not one we use to embed an image, it won't display a secret image. All right, so now we embedded 10 images, 10 secret images into one image, and we can load that image now. We named it 10 secret images. And now if we go through, we can look at all these different recovery methods, and there's a different secret image hidden in each of them. So we're going to go through, and there's 10 secret images that we hid, but for these two, it's not going to display anything because we have actually 12 embedding techniques, but there were only 10 secret images loaded.
Alright, this is the flatten function. It takes an image as an input and then outputs flatpick, which is just a more simplified version of image essentially. The function consists basically of a for loop that goes through the original image, and if the value is greater than 120, it makes the corresponding position of the new array 0, while if the original image is less than 120, the corresponding of the new array will be 1. And so then it just outputs this new array. This is the expand function. It goes along with the flatten function, and it takes the output from the flatten function and converts the array back into a RGB image in the form of everything's black and white. Basically, if the original or the flat image value is 1, the new array image will have a value of 0, while if it was 1, it's now 255, and you end up with, when you combine the flatten and expand images, you end up with a black and white version of the original image you put into flatten, which comes out as expand image.
So this is a binary embedding function, and it can handle up to 12 different images. So what you do is you pass in your image, which is the RGB image you want to embed everything in, your hidden image, which is what you want to hide, wants to be hidden, the color, which is a value of 1, 2, or 3, which corresponds to red, green, or blue, and your value, which is either 1, 2, 4, or 8, and this represents which binary bit you want to manipulate. So the way the function works is it first flattens the hidden image to make it only zeros and ones, and then what it's going to do is it's going to for each pixel, there's 8 bits to represent the data, either 1 or zeros, and it's going to manipulate whichever place value you select, so the 1s, 2s, 4s, or 8s place, and automatically at first it sets it all to be 0. And then you're going to add it to your hidden image times your value, which basically makes it so that it has a 1 there if your hidden image is a 1, and 0 otherwise. So this is the binary recovery function, which recovers the hidden image out of your embedded image. So it takes in the embedded image as an input, as well as the color and value. The color and values have the same values or optional values as they had in the binary embedding. So basically what this does is it goes to the embedded, takes the image of your color layer you want, and then looks only as it's the binary bit that your place value had, and then it divides it by the value, which essentially, if it's a 1 at place value, it makes a 1 in your hidden image. If it's a 0 at place value, it stays 0. And then you expand the hidden image back out, and that's it. For GUI, we also added checks to make sure the user loaded appropriate images. So we make sure the normal image that is loaded has 3 layers, so it's an RGB image as opposed to 1 layer. And we also make sure your secret image only has 1 layer, so the flatten expansion works, and that it's also the same size as your image. We also ensure that the embedded image is 3 layers, so you can pull out your hidden images.
And like every evil genius, I'm petting a cat in this video.